start with solving quadratics by graphing. You will need I want you to have a graphing calculator for what we're doing today. So if you don't have one, grab one, please. So page 283 of your student journal, solving quadratic equations by graphing. I want you to take a look at those 3 steps. Make sure you understand what each of them is saying. So step 1, write the equation in standard form. In other words, set it all equal to 0. Step 2, graph it. Step 3, find the x-intercepts, which we also call, x-intercepts are also called solutions or roots. Okay? We did a little of this last chapter. All right, so let's go ahead and try some of this out here. Let's take a look at page 284. All right. We're going to work through 3 problems on page 284 together. Okay? To begin with, I want everyone to do the first step for 1, 2, and 3. Do the first step. You should not need a calculator, but apply that first step from page 283. Okay, hopefully we're done. Number 1, if we're writing them all in standard form, this one's already set equal to 0. X squared is first, then x, and then we're good. Number 2, it's not set equal to 0. We'd want to get x squared over on this side. It's nice to make that a positive, so we're going to have x squared by adding x squared over minus 2x plus 1 equals 0. And then this one, are we good? Yeah? All right. Very good. So we've got standard form. Well, those are the 3 we're going to graph here in a minute, but I want you to go through 4 through 9 and tell your neighbor which one is not in standard form and how to get it in standard form.
Number 6 isn't.
Okay, get it in standard form once you find it. Okay, so number 6 wasn't. You would move the 2x over by subtracting. You'd move the 6 over by adding. Okay, so that goes over, all equals 0. Now it's in standard form. So once we set it equal to 0, please note that when you're graphing, because we want to try to keep x squared as positive. Okay? Yeah, that's why we didn't move the x squared. It's always nice to leave x squared as positive. It makes it easier to factor doing that. Okay? So what I want to do on number 1, I want you to factor number 1 to begin with. Okay, factor it. What comes out of both x squared and x, or 4x? X. Okay, fill out your parentheses there. Okay, what's this factor to? X times x and x times 4. All right. Now remember when we solved these, we would set this part equal to 0. If this times this equals 0, then one of those 2 things has to be 0. So we'd set x equal to 0, and we'd set x plus 4 equal to 0. And if x plus 4 equals 0, what's x equal? X equals negative 4. Okay? Those are your x-intercepts. All right? That's where our graph crosses the x-axis. Crosses here at 0, and if we're going up by 1s on the x-axis, crosses here at negative 4. What is your y value right here? When x is 0, what's y here? What's your y value on this one? Everyone agree it's 0? Okay. Yeah. Your x-intercept is always when y is 0. Hi, Sarah. You're negative 4. X, so factoring. X times what is x squared? X times, okay. All right, so those are our x-intercepts. That's where it crosses. What I want you to do now is I want you to take your graphing calculator. And since y equals 0 both right here and here, the same thing as having x squared plus 4x equals 0. It's the same thing as saying x squared plus 4x equals y. We're just substituting a special value in for y. We're substituting 0 in. That's our y-intercept. So I want you to go to your y equals menu. Okay? So for those of you that can't recall how to graph, your whole graphing feature is up on the top row here. We're going to go to y equals, and I've already put in x squared plus 4x. I've actually put in some other ones as well. Let's focus in on the x squared plus 4x. If you're using x, the x you want to use on your calculator is this one right here. That's your variable button. Okay? So you're going to put in your x squared plus 4x, and then go ahead and hit graph. Okay? If your screen does not look like this, make sure you're zoomed to the standard viewing window. The way you do that, you have to find the zoom button. Everyone finds zoom, even if your graph looks like that. Zoom, this middle button right here. And you want to go to the standard window, which would be option 6, zoom standard. Okay, and it'll bring you to that. That's where it goes from 10 to negative 10, negative 10 to 10. Okay? Please note, if I want to see the table for this, so I can see what the x-intercepts are, ladies, we go second graph, we go to our table feature.
I did it right.
Okay? And the x-intercept is when y is 0. Notice we got negative 4, 0, and we have 0, 0. Both of those values. Those are our x-intercepts. Please also note, if I look at negative 2, negative 2 is negative 4. Notice on either side of this, negative 4, notice these values here. You have 5, 5, 0, 0, negative 3, negative 3. That means this point right here is our
X-axis. No, I don't know. Oh, it's the middle part.
Yeah, it is the middle part. I want everyone to graph these points right here. From negative 5 to 5, 1 to 5. Okay, graph those on your coordinate plane, please.
I'm a smart person.
Second table. Okay, so plotting that points, what do you see right there? Yeah, you see a parabola. What was this point right here where we started getting the same values on both sides? What is that point called? That is the axis of symmetry. Very good. Okay? X equals negative 2. Axis of symmetry. Okay? So when you're looking at your table, you're looking for that reflection of points. Helps out. Yeah?
Is there any way you can find the axis of symmetry without graph?
That's the opposite of b over 2a.
Oh.
Yep. Hey, yeah, you could have done x equals opposite of b over 2a and found that. Right? Negative 4 divided by 2 is negative 2. Okay? What are the solutions to this equation? Tell your neighbor what your solutions are. What's one solution? Sebastian, what's one? Yeah, 0, negative 4. Not quite 0, negative 4. Negative 4, 0 would work, yeah. So x equals, what does x equal in the negative 4, 0? Negative 4. That's one solution. Okay, what's another solution? This point right here. Yeah. 0, 0. So x equals 0. Okay, we're only worried about the x values. Why? Because there's x right there. X equals negative 4 and x equals 0. Also written as x equals negative 4 and 0 using set notation. It's where the graph crosses the x-axis. Okay, how many times does this graph cross it?
Twice.
Twice. That means there are two solutions. Could you ever get more than two solutions? Yeah, if it curved back down, right? But that would change it from a squared to a cube, right? It could be a third degree then. A squared can only cross twice. This number right here, your highest power is the greatest number of solutions you could potentially have. So if this was x to the 100th, you could potentially have 100 solutions. That means your graph could cross the x-axis 100 times. Okay? Just like in linear, remember when we had like 4x plus 5? It's a straight line. It can only cross once. Okay? That's not the graph of that, by the way, but that's okay. It can only cross once. Okay? I want everyone to graph number 2, please. What's that, Logan?
If it's just x, it would just be...
Yeah, if it's x to the first, it could only cross once. But we're dealing with x squared. Yep.
But they teach us like...
So even if you put it in the calculator in this format, it'll still come out the right way?
Yeah, in the x squared minus x plus 1. Yep.
You know, these are my...
Okay, ladies and gentlemen, I put my equation in the second menu here, and I'm turning that one on. Notice when I have multiple equations in, so I just put mine in the second. You probably have yours in the first, but notice my equal sign is lit up there. It's not up there. That just means it's only going to graph that one. So x squared minus 2x plus 1, I hit graph. How many times does it look like it hits? Looks like it hits at 1 at 1. Let's verify that. We go to our table. Y equals 0 when x is 1. Notice that point also is, what do we note about that? Hey, what's happened with our table right here? Yeah?
Y is at 0, x is at 1.
Okay. What else? Look at your y values. You're skipping? Does everyone see the symmetrical piece here? We have 1, 1, 4, 4, 9, 9. Okay? Yep. Let's go ahead and graph that.
Would you start graphing that at 0, 1?
You guys, what's this called right here when we have those points? You start repeating. That's our axis of symmetry. That's what we're looking for in the table. Okay, how many solutions? One solution. Tell your neighbor what the solution to this equation is. X equals... This is x equals 1. Only crosses at 1. That is our solution. Also happens to be our axis of symmetry. But
Oh, wait, so there wouldn't be an x-intercept?
there is.
Oh,
It's at 1.
oh, yeah.
Yeah. Hey, did anyone try
Yeah,
graphing it?
Thinking.
Anyone try graphing it by factoring? All right. All right, number 3. Give it a shot there. Put it in your calculator. Okay, here we go. How many times this one crossed the x-axis? 0. How many solutions are there? There are going to be no solutions here. If I am graphing this, turn around. Okay. Are you guys doing anything? Doesn't look like it. Let's see your book.
You can see it.
Oh,
Okay. What you got on your calculator? All right, thank you. What do you got? Come on, man.
Sort of following along.
Sort of will help your grade if you follow along. Sort of. Just saying. All right. hey, it has 0 solutions. Looking at your table, I'm hoping you guys can start picking out where that axis of symmetry is. When you usually initially hit your table, notice on this one, it's going upward. If you keep going until your graph starts going up again in the other direction, and then look for that mirror, 12, 12, 7, 7, 4, 4, 3. Okay, that is pretty close, if not your axis of symmetry there. In this case, this is your axis of symmetry. So you go to negative 1, 3. We go to 0, 4. Okay, get those 2 points there. This graph isn't going to cross the x-axis, so when we have that, that is a no solution. No solution on that one. So we had 3 different scenarios today. Tell your neighbor when you will get 1 solution, when you get 2 solutions, and when you'll get no solutions.
When there's no x-axis. There's no point on the x-axis. There's no solution.
If it's under the...
Okay, Isaiah, when will we get 1 solution? Hey, I need your attention back up here. Isaiah, when do we get 1 solution? Good, when it hits the x-axis once. When do we get no solutions, Bailey? When do we get no solutions? Yes, we did on number 3. I agree. When will we get that? Mercedes? When it doesn't touch the x-axis. When do we get 2 solutions, Kai? Very good. So on number, go ahead and turn your page over. I want you to take a look at number 10. Tell your neighbor what the solutions to those functions are. Or to that function is.
1 is...
Hey, time's up. X, what's 1 solution? Yeah. 0. Okay, crosses right there. 0. Quentin, what's another? 1. Okay, and the last one, Sergi? 2. Okay, how many total solutions? 3. Tell your neighbor what we talked about today that could have told you ahead of time that there might be 3 solutions. Yeah. Yeah, if there's 3 x's. Notice this is x to the first and this is x to the third. So when we're saying 3 x's, we mean x to the 3rd power, right? Okay? What's the highest power here? Well, we have x times x squared would be x cubed. How many solutions are on this one, though? Back. 2. There and there. So just because it's x cubed doesn't mean there will be 3 solutions. It means there could be at most 3. Okay? So that is negative 2 and 1. Okay, I want you to fill out the solutions for the rest of the problems on that page, please. Okay, checking your work. Yeah, they are. Just their equations look different. But they are the same. Because one, they factored it 2 different ways. Yeah. So it is the same thing. Okay. 16 through 18. That's kind of estimated, right? You're supposed to estimate on those.
How'd you get?
Which one?
You got like 2.6 and 2.3 on the bottom ones.
Yeah.
I put 25.25.
20.25. Which one? Right here? Which one? This one?
Yeah. That one.
So 1, 2, and about a third. 2.3-ish.
Oh.
Yeah. Hey, any questions?